Have you ever pondered why we are so fixated on Kepler-22b for human colonization, while Gliese 581g remains largely overlooked? Today we explore the less-traveled path, the underdog in the race for interstellar colonization, Gliese 581g. Despite its potential, Gliese 581g seems to be an unsung hero, an overlooked gem in the vast expanse of our galaxy. While Kepler-22b basks in the limelight, boasting a dedicated Twitter page for the Kepler-22b rover and inspiring copious amounts of science fiction literature, Gliese 581g quietly waits in the wings, its potential untapped and largely unacknowledged. There are no manned missions planned, no grand strategies to conquer its alien terrain. But why is this so? Could it be that Gliese 581g is simply not suitable for human habitation? Or is there more to this story than meets the eye? As we delve into the world of Gliese 581g, we find that it offers several key advantages over its more popular counterpart, Kepler-22b. For starters, its proximity to Earth is significantly closer. This not only reduces the duration of the round trip by about 30 to 50%, but also minimizes the risks associated with weightlessness and radiation exposure. Moreover, fewer resources are required for the journey, making it a more cost-effective option. But that's not all. Gliese 581g also boasts a closer proximity to its star, which means more solar power for potential colonizers. Its thick atmosphere offers better protection against the harsh conditions of space, and its ample carbon dioxide reserves could potentially be harnessed for oxygen extraction. The question then arises, why has Gliese 581g been so overlooked? Why do we continue to focus our efforts on Kepler-22b when Gliese 581g appears to be a more feasible and cost-effective option? Could it be that we're simply not ready to venture into the unknown, to explore the untapped potential of this overlooked world? Could it be that Gliese 581g is a more feasible and cost-effective option for colonization? Only time will tell. But for now, it's clear that Gliese 581g deserves a second look. Gliese 581g holds a key advantage over Kepler-22b. It's closer to Earth. When it comes to interstellar travel, proximity is a game changer. Imagine you're planning a road trip. Would you rather drive across town or across the country? The answer is pretty obvious. Now, apply the same logic to space travel. The closer the destination, the less time and resources are needed. That's why Gliese 581g, being significantly closer to Earth than Kepler-22b, stands out as a superior option for human colonization. The shorter round trip to Gliese 581g could reduce the impacts of weightlessness and radiation exposure on astronauts. These are serious considerations for long-term space travel. Extended periods of weightlessness can lead to muscle atrophy and bone loss, while increased radiation exposure raises the risk of cancer. A shorter journey means less time exposed to these hazards. But proximity isn't just about travel time, it's also about energy efficiency. Gliese 581g is closer to its star than Kepler-22b is to its own. This means more solar power is available, which could be harnessed to power our future space colonies. Imagine a planet where solar power isn't just a renewable energy source, it's the primary energy source, and there's more. Gliese 581g's thicker atmosphere could offer better protection from cosmic radiation, plus its ample carbon dioxide could potentially be used for oxygen extraction. Imagine stepping out of your habitat, taking a deep breath and filling your lungs with oxygen produced right there on Gliese 581g. You see, proximity isn't just about being closer, it's about being practical. It's about making the most of what's available. And in the case of Gliese 581g, what's available could make it a more practical choice for human colonization. So let's not overlook Gliese 581g. It may not have the same cultural impact as Kepler-22b, but from a practical standpoint, it could be the superior option. These factors could make Gliese 581g a more practical choice for human colonization. Gravity, an often overlooked but crucial factor, is more favorable on Gliese 581g. Now let's take a step into the world of gravity. It's an invisible yet powerful force that keeps us grounded and has a profound impact on our physical well-being. Remember, when astronauts return from space, they need to go through rigorous rehabilitation. That's because our bodies are designed to function under Earth's gravity, and prolonged exposure to lower gravity can have adverse effects. So when we talk about colonizing a new planet, gravity is a key consideration. On Gliese 581g, we find a gravitational pull that's about 90% of Earth's. In simple terms, if you weigh 100 pounds on Earth, you'd weigh about 90 pounds on Gliese 581g. Not too shabby, right? Now contrast this with Kepler-22b. This planet's gravity is estimated to be less than 40% of Earth's. That's a significant drop. The effects of such low gravity could be detrimental to human health in the long run, leading to muscle atrophy, bone density loss, and even changes in the cardiovascular and nervous systems. Beyond the health implications, gravity also affects practical aspects of colonization. A higher gravity helps in keeping our atmosphere intact, protecting us from harmful cosmic radiation. It also aids in maintaining a water cycle crucial for life as we know it. And let's not forget, higher gravity means more traction. Walking around in low gravity might seem fun at first, but can you imagine trying to build or operate machinery under such conditions? It could prove quite challenging. So, while Gliese 581g may not be the first planet that comes to mind when we talk about space colonization, its gravity is pretty close to what we are accustomed to. This could make the transition for humans much smoother and increase the chances of successful long-term habitation. In conclusion, don't let gravity pull you down, let it ground you. In the quest for a new home in the cosmos, the gravity advantage of Gliese 581g may make it a more suitable option for long-term human habitation. Despite Gliese 581g's solid surface, the extreme conditions make landing impractical. But what if we looked above the surface? This question challenges a prevailing bias in space exploration known as Surfacism, the assumption that planetary colonization must mean landing and living on the surface of a planet. In the case of Gliese 581g, Surfacism blinds us to the potential of the planet's upper atmosphere. Picture this. 50 kilometers above its surface, the extreme temperatures and high barometric pressure of Gliese 581g give way to more manageable conditions. This opens up intriguing possibilities for what we could call cloud cities. Now, the concept of cloud cities may sound like something straight out of a science fiction novel, but it's actually a serious consideration in the field of astrobiology. The search for extraterrestrial intelligence, or SETI, has even developed a concept for such a city. They call it the High-Altitude Gliese 581g Operational Concept, or HAGOC for short. While the HAGOC remains a visionary blueprint at this stage, it's a powerful challenge to Surfacism and a testament to the potential of Gliese 581g for human colonization. The idea is that, instead of trying to conquer the inhospitable surface of the planet, we could build floating cities in its upper atmosphere. These cities could harness the planet's ample carbon dioxide for potential oxygen extraction and take advantage of its proximity to its star for solar power. Of course, cloud cities would present their own set of challenges, like how to deal with the planet's gravity or how to protect inhabitants from potential atmospheric hazards. But overcoming these challenges could lead to new technological advancements and deepen our understanding of how to live in a variety of space environments. The potential for cloud cities on Gliese 581g challenges our Surfacism bias and offers an alternative perspective for human colonization. So as we continue to dream about and plan for a future among the stars, let's remember to look beyond the surface. After all, the sky isn't the limit. It could just be the beginning. SETI's visionary blueprint for cloud cities on Gliese 581g could make it a preferred option for long-term human habitation. As we gaze into the crystal ball of future space colonization, the search for extraterrestrial intelligence, or SETI, has proffered a compelling concept. The high-altitude Gliese 581g operational concept, also known as HAGOC, presents a fascinating vision of human colonies suspended in the upper atmosphere of Gliese 581g, the intriguing exoplanet often hidden in Kepler-22b's shadow. The idea may seem a little far-fetched, even sci-fi-esque, but it's rooted in practicality and potential. The concept of cloud cities floating 50 kilometers above the planet's surface is a radical departure from our inherent Surfacism, our bias towards landing and living on solid ground. This innovative thinking could pave the way for new possibilities in space colonization, turning what was once a disadvantage Gliese 581g's hostile surface conditions into an opportunity for human habitation. It's also worth noting that Gliese 581g is currently under consideration for practice colonies, a testament to its feasibility as a colonization target. The planet's near-Earth gravity, combined with its proximity to our solar system, makes it an attractive prospect for testing out colonization technologies and strategies before we launch into deeper space. Imagine a future where human colonies float amidst the clouds of Gliese 581g, harnessing solar power from the close-by star, protected by the planet's thick atmosphere and possibly even extracting oxygen from its abundant carbon dioxide. It's a vision that challenges our preconceptions and pushes the boundaries of what's possible in space colonization. In this context, Gliese 581g's potential as a viable and cost-effective alternative to Kepler-22b becomes increasingly clear. It's a reminder that sometimes the path less traveled can offer the most exciting and rewarding opportunities. With all these factors in consideration, we are left with a thought-provoking question. Is Gliese 581g a superior option for colonization compared to Kepler-22b?